Ladies and gentlemen, imagine waking up one morning to find that the technology you trusted to drive you safely has changed overnight. And the feature you thought was permanent is gone. Tesla is rewriting the rules of what a car can do, evolving faster than any human driver could, and what you see today is only the beginning. This isn't just an update. It's a glimpse into a future where vehicles think, learn, and improve themselves while you're behind the wheel. Stay with us because what comes next will redefine everything you know about driving. When customers choose a Tesla, they are not simply purchasing a vehicle, they are investing in a continuously improving technology platform. Unlike traditional automobiles that remain largely unchanged after delivery, Tesla vehicles evolve through over-the-air software updates designed to enhance safety, intelligence, and performance. That commitment to constant refinement sometimes leads to bold decisions that reshape features in real time. In the case of Tesla removes Autopilot overnight, buyers are stunned. The focus is not on subtraction, it is on strategic advancement. An Autopilot has always been designed as a driver assistance system, built around safety and real-world data. From its earliest versions, it has relied on neural networks trained across billions of miles of driving data collected globally. As Tesla's artificial intelligence systems mature, the architecture supporting Autopilot continues to transform. When a feature changes, updates, or is removed, it reflects a deliberate engineering decision driven by data, regulatory alignment, and the pursuit of a more unified autonomy stack. And in some cases, certain legacy Autopilot configurations may be retired to streamline the transition toward a vision-based system. Tesla's shift to Tesla Vision eliminated reliance on radar in favor of camera-based perception powered by advanced neural networks. This move simplified hardware complexity while improving scalability. Removing or redefining specific Autopilot functionalities can occur when the company transitions toward a more capable full self-driving framework, ensuring that every vehicle operates on a consistent software foundation. And for buyers, an overnight change can feel sudden. However, Tesla's software ecosystem operates with agility similar to leading technology companies. Updates are deployed across fleets simultaneously, allowing improvements to reach customers without service appointments or hardware recalls. While traditional automakers schedule model year changes, Tesla refines vehicles in real time. This approach can occasionally create moments of surprise, but it is rooted in rapid innovation and safety optimization. And safety remains the core principle behind Autopilot evolution. Every change is measured against real-world performance metrics. If a feature does not meet Tesla's internal safety benchmarks or regulatory expectations, it may be recalibrated, restricted, or temporarily removed while improvements are deployed. This ensures that the system aligns with the company's long-term autonomy roadmap, while maintaining transparency about driver responsibility. And Tesla's philosophy has always centered on continuous improvement. Just as smartphones receive operating system updates that replace older functions with more advanced capabilities, Tesla vehicles adapt as software matures. What may appear as a removal is often part of a larger integration strategy, merging Autopilot and full self-driving capabilities into a unified AI model trained end-to-end. This end-to-end neural network approach enables smoother decision-making, improved object detection, and more natural driving behavior. And customers are not left behind in this transition. Tesla provides release notes and in-car notifications detailing system changes. The company's support infrastructure ensures that drivers understand how features operate and what responsibilities remain with the human operator. Autopilot continues to require active supervision, and Tesla reinforces this standard through driver monitoring and interface prompts. And the larger vision remains unchanged, accelerating the world's transition to sustainable energy while leading the development of autonomous mobility. As Tesla vehicles become more intelligent through software-defined architecture, the company prioritizes adaptability. Hardware 3 and newer computing platforms are designed to handle increasingly complex neural networks, ensuring that today's vehicles are prepared for tomorrow's autonomy milestones. And moments that generate headlines often reflect the pace at which Tesla innovates. Rapid deployment, AI-driven refinement, and real-time optimization are core characteristics of a technology-first automotive company. Buyers may initially be surprised when a feature changes overnight, but that agility is precisely what differentiates Tesla from legacy automakers bound by slower development cycles. And Autopilot's evolution represents progress toward a safer, more capable autonomous future. Every software decision, including the removal or restructuring of features, is aligned with long-term performance goals, fleet-wide learning, and regulatory responsibility. Tesla vehicles are built not only to drive, but to learn, adapt, and improve continuously as artificial intelligence advances. And that philosophy is embedded in the very architecture of every Tesla vehicle. From the moment a car leaves the factory floor, it is connected to a secure digital ecosystem that allows engineers to analyze anonymized driving data, refine neural networks, and deploy calibrated updates across the global fleet. This feedback loop is one of the most powerful differentiators in modern automotive engineering. It allows Tesla to move beyond static feature sets and toward a living platform that grows more capable over time. And when adjustments to Autopilot occur, they are guided by real-world edge cases and billions of miles of diverse driving scenarios. Complex intersections, unpredictable pedestrian behavior, varying weather conditions, and evolving traffic patterns all contribute to the continuous retraining of neural networks. If a feature does not align perfectly with the system's expanding AI model, it may be consolidated or redesigned to ensure a seamless unified driving stack. This prevents fragmentation between legacy systems and the next-generation autonomy architecture. And Tesla's transition toward an end-to-end AI model reflects a broader technological evolution. Rather than relying on separate modules stitched together through rule-based programming, Tesla's neural networks process visual input directly and generate driving outputs with increasing precision. This holistic approach reduces latency, improves adaptability, and enhances the system's ability to generalize across unpredictable road conditions. As the software matures, older intermediate layers may become unnecessary, paving the way for streamlined functionality. And for customers, this transformation underscores a new ownership experience. A Tesla is not defined solely by its hardware at delivery. It is defined by its capacity to improve. Vehicles equipped with advanced onboard computing are designed to support increasingly sophisticated neural networks. Hardware redundancy, optimized power efficiency, and AI-focused chipsets provide the foundation for long-term scalability. In this context, software evolution is not disruption, it is progression. And regulatory landscapes also play an important role in shaping feature deployment. Autonomous driving technologies operate within complex global frameworks that vary by region. Tesla continuously aligns its software capabilities with regulatory standards to ensure compliance and responsible rollout. If requirements shift or new guidance emerges, features may be adjusted accordingly. This adaptability allows Tesla to maintain leadership in innovation while prioritizing safety and transparency. And communication remains central to this process. Tesla's in-vehicle interface provides detailed release notes outlining enhancements, refinements, and behavioral adjustments. Drivers receive clear instructions regarding supervision requirements and operational parameters. Autopilot remains a driver assistance system, and Tesla consistently reinforces the importance of attentive driving. Updates that modify system behavior are accompanied by educational prompts to ensure a smooth transition. And beyond Autopilot itself, Tesla's broader AI ecosystem continues to expand. The same neural network principles guiding driver assistance are being applied to energy optimization, battery management, and predictive diagnostics. Machine learning algorithms analyze usage patterns to maximize efficiency and extend vehicle longevity. This integration of AI across vehicle systems reflects Tesla's identity as both an automotive manufacturer and a technology innovator. And the pace of change can challenge conventional expectations. Traditional vehicles often remain unchanged until the next model year, but Tesla operates on software cycles measured in weeks rather than years. This dynamic development model enables rapid response to insights gathered from the fleet. It allows improvements to propagate globally with unprecedented speed, reinforcing the company's commitment to delivering safer and smarter transportation solutions. And in moments when buyers express surprise, it is important to recognize the larger trajectory. Autonomous capability is not a single feature. It is a continuum of refinement. Each update represents a step toward higher levels of intelligence, perception, accuracy, and decision-making capability. Temporary removals or consolidations serve the purpose of strengthening the overall system architecture, ensuring that every component aligns with the long-term autonomy roadmap. And Tesla's data-driven methodology ensures that progress is measurable. Safety reports, performance metrics, and real-world validation guide engineering decisions. Every modification undergoes simulation testing and fleet-level validation before deployment. This rigorous process balances innovation with responsibility, allowing Tesla to push technological boundaries while maintaining high safety standards. And the evolution of Autopilot is part of a broader shift toward software-defined vehicles. As artificial intelligence continues to advance, Tesla's vertically integrated approach, combining hardware design, AI chip development, and neural network training, positions the company to iterate rapidly and cohesively. Changes that occur overnight are not isolated events. They are milestones within an accelerating journey toward fully autonomous mobility powered by continuous learning, real-time data, and an unwavering focus on technological advancement, and this journey is reinforced by Tesla's vertically integrated manufacturing and software strategy. By designing its own AI chips, building proprietary neural network training infrastructure, and controlling the full software stack, Tesla eliminates dependencies that traditionally slow automotive innovation. Every component, from silicon to user interface, is engineered to operate as part of a cohesive intelligence platform. When a feature like Autopilot evolves, it does so within a tightly synchronized ecosystem built for rapid iteration and scalable deployment. And at the core of this ecosystem is Tesla's custom-designed full self-driving computer capable of processing immense amounts of visual data in real time. Each vehicle acts as both a product and a contributor to the broader learning network. Driving data anonymized and securely transmitted enables neural networks to refine object detection, depth estimation, motion prediction, and path planning. The removal or consolidation of specific Autopilot elements reflects the transition from earlier perception stacks to increasingly advanced AI-driven reasoning models. And fleet learning is central to this process. Edge cases that once challenged driver assistance systems, unusual road markings, temporary construction zones, rare traffic behaviors, are identified and fed into large-scale simulation environments. Tesla's AI training clusters process these scenarios to improve decision-making accuracy. As the system matures, simplified architectures replace legacy redundancies, ensuring cleaner integration and more efficient computation. What may appear as a feature being taken away can represent the elimination of transitional code that no longer serves the long-term neural architecture. And Tesla's approach to innovation is rooted in first principles. Instead of layering incremental changes onto outdated frameworks, the company regularly rethinks the entire stack. This mindset has driven the transition to vision-only perception, the development of end-to-end neural networks, and the move toward unified planning systems. Autopilot's evolution mirrors these foundational shifts. By aligning all vehicles under a common AI framework, Tesla accelerates progress toward higher autonomy levels while reducing system complexity. And customer experience remains a priority throughout this transformation. Tesla's vehicles are designed with intuitive interfaces that communicate system status clearly. Visualizations on the central display provide real-time feedback about what the vehicle perceives, surrounding cars, lane markings, pedestrians, traffic signals. As software updates refine perception models, these visualizations become more precise and natural, reinforcing driver confidence. Changes to Autopilot behavior are calibrated to ensure smooth adaptation without compromising usability. And battery efficiency and energy optimization are also enhanced through software refinement. Tesla's integrated AI models evaluate driving style, terrain, and environmental factors to maximize range. Updates that streamline computing processes can improve overall system efficiency, reducing energy consumption associated with onboard processing. This synergy between autonomy and energy management reflects Tesla's broader mission to deliver sustainable mobility powered by intelligent software. And global scalability is another defining element. Tesla deploys updates across diverse markets with varying road infrastructures and driving cultures. The adaptability of its AI models allows for consistent performance across continents. When features are adjusted, it ensures uniform system behavior, aligned with regional regulations and infrastructure differences. This global fleet provides a scale advantage unmatched in the industry, accelerating learning cycles and enabling rapid feature evolution. And behind the scenes, Tesla's simulation capabilities play a critical role. Advanced virtual environments replicate millions of miles of driving conditions, allowing engineers to validate neural network performance before public release. Scenario-based testing ensures that changes enhance safety metrics and driving smoothness. The removal of certain legacy functions can reduce conflicting behaviors within the software, creating a more coherent driving experience, aligned with the next-generation autonomy vision. And transparency and innovation is part of Tesla's identity. The company regularly publishes safety reports comparing Autopilot engagement metrics to national driving averages. These data-driven disclosures reinforce the focus on measurable improvement. Each software revision is assessed not only for capability expansion, but for tangible safety impact. Adjustments that may surprise buyers are anchored in these quantitative evaluations. And Tesla vehicles are increasingly defined by software intelligence rather than mechanical complexity. As artificial intelligence capabilities grow exponentially, Tesla continues refining its vehicles to reflect the latest advancements. The pace of iteration, the integration of AI at every layer, and the strategic simplification of legacy components all point toward a singular objective: delivering a transportation platform that learns, adapts, and evolves in real time. Overnight changes represent the visible surface of a deeper transformation powered by neural networks, data scale, and continuous engineering refinement that pushes the boundaries of what modern vehicles can achieve. And as artificial intelligence continues to compound in capability, Tesla's internal development cycles become increasingly centered on neural network scale and data efficiency. Training models now incorporate exponentially larger datasets, allowing the system to interpret subtle environmental cues with greater contextual awareness. Road textures, lighting shifts at dusk, rare signage variations, and unpredictable driver behaviors are absorbed into the learning architecture. When software evolves, it is not merely an update in code, it is a refinement of perception itself, reshaping how the vehicle understands the world around it. And Tesla's Dojo training system further amplifies this progression. By building purpose-designed AI training hardware optimized for computer vision workloads, Tesla reduces dependency on third-party infrastructure and accelerates iteration speed. Faster training cycles mean that improvements discovered in one region can be modeled, validated, and distributed globally within compressed timelines. This velocity is fundamental to why feature sets may transform rapidly. The system is not static. It is continuously retraining against new inputs, and the production fleet reflects those advancements in near real time. And the architecture guiding Autopilot and full self-driving increasingly relies on occupancy networks, models capable of reconstructing a three-dimensional understanding of surroundings from camera inputs alone. Rather than identifying isolated objects, the system interprets continuous space, predicting movement trajectories and environmental boundaries simultaneously. As this approach matures, legacy rule-based layers become redundant. Streamlining those layers improves computational efficiency and reduces potential conflicts between subsystems, enabling smoother, more human-like driving behavior. And Tesla's commitment to software-defined vehicles also enhances long-term product value. Unlike conventional cars that depreciate strictly through wear, Tesla vehicles retain the potential for capability expansion. Advanced driver assistance improvements, refined visualization systems, and optimized route planning algorithms can be delivered years after purchase. The removal of transitional features is often part of consolidating toward stronger foundational systems designed to support broader autonomy objectives. And driver engagement remains a critical component of the Autopilot framework. Tesla continuously refines cabin monitoring systems and steering torque detection to ensure active supervision. Updates to these systems are guided by safety analytics, identifying patterns that reinforce responsible usage. By integrating machine learning into driver monitoring, Tesla enhances compliance with global safety standards while preserving user convenience. And the broader ecosystem surrounding Tesla vehicles also contributes to ongoing refinement. Supercharger network data informs route optimization algorithms, enabling more precise energy predictions and travel planning. Traffic pattern analysis improves navigation efficiency, while over-the-air diagnostics anticipate maintenance needs before issues arise. Each of these software domains operates within the same AI-driven infrastructure that powers Autopilot, creating synergy across vehicle functions. And Tesla's manufacturing innovations complement its software agility. Gigafactories incorporate advanced automation and vertically integrated supply chains, enabling hardware iterations that align seamlessly with evolving software demands. When onboard computing requirements shift to accommodate more advanced neural networks, Tesla's hardware platforms are designed with sufficient overhead and redundancy to scale. This forward-looking engineering ensures that vehicles delivered today are equipped to support tomorrow's algorithms. And public discourse surrounding feature changes often reflects the novelty of Tesla's approach rather than regression. In traditional automotive frameworks, removing a feature would signify limitation. Within Tesla's technology-driven model, recalibration signifies optimization. Simplifying system architecture reduces maintenance complexity, improves reliability, and enhances long-term scalability. Each refinement strengthens the integrity of the unified autonomy stack. And the data flywheel effect continues to accelerate progress. As more vehicles operate globally, the diversity of scenarios captured expands exponentially. Urban density, rural road conditions, extreme climates, and evolving infrastructure all contribute to richer model training. This global dataset allows Tesla to generalize solutions across environments, minimizing region-specific discrepancies. Feature evolution becomes part of a synchronized global upgrade cycle. And Tesla's vision extends beyond incremental driver assistance. The company is architecting a foundation for advanced autonomous capability that prioritizes safety, adaptability, and computational efficiency. Each software decision, including restructuring or removing intermediate features, aligns with the objective of delivering cohesive end-to-end autonomy powered by neural networks. The visible changes experienced by drivers represent the surface layer of a deeper technological transformation driven by continuous AI research, vertically integrated engineering, and fleet-wide learning at unprecedented scale.